What's up, Seattle Seahawk fans? It's Miss Sorensen with video 28. Today we're going to combine permutations and combinations with the probability distribution table problems. Let's get started. Historically, during the first 3 days in July, the probability of having a smoky sky in Manson is 60% each day. Let S be the number of smoky days and create a probability distribution table for S. Okay. Well, if we're talking about the first 3 days in July, and we're talking about the number of smoky days, what options do we have? Well, the possibilities are we can have 0 smoky days, we could have 1 smoky day, we could have 2 smoky days, or we could have 3 smoky days. So those are all the possibilities when we're talking about 3 days. The other thing I think it's really important to write down is what the information you're given is. So having a smoky sky in Manson is the probability of smoky is equal to 0.6. I highly recommend writing that down. It's really important because you also need to write down the probability of not smoky. What would be the probability of not smoky? Well, that would be just 0.4 because we know that those have to add up to 1. They're complements. All right, so if we are having 0 smoky days, that means we have not smoky, not smoky, not smoky. So that's going to be not smoky, not smoky, not smoky. Well, what's the probability of not smoky? On the first day, it's going to be 0.4, the second day, 0.4, the third day, 0.4. So we're just going to multiply 0.4 times 0.4 times 0.4, and that's going to be our answer there. And on these problems, I don't need you to multiply these things out. I just want to see things like that. If you want to put your little star, you're welcome to. Okay. All right, so there we go. We've got that in there. Now, what about having 1 smoky day? Well, let's say the smoky day is on the first day. We've got 0.6 on the first day, and then we've got our second day is going to be not smoky, and then our next day is not smoky. But then let's say that our smoky day is actually on the second day, so then we've got 0.4 times 0.6 times 0.4, and then we've got the smoky day on the last day would be our other option, 0.4 times 0.4 times 0.6. Okay, and so basically you're saying that you've got 1 smoky day for one option, another smoky day here, and another smoky day here. So I'm just going to erase that, and let's just get the non-writing version, the computer version of that. Oopsie. There we go. And it looks like they've already done 3 for me, or I kind of did that myself. Let's just make sure this makes sense. 3 smoky days should be a smoky, and a smoky. So we've got 0.6 times 0.6 times 0.6, which makes total sense. Okay, how about this last one? Maybe pause the video and try it on your own. This is talking about 2 smoky days. All right, tell me if you got this. So you remember, smoky stands for the 0.6. That's why I asked you to write it down, because it really can get confusing. So you've got 2 smoky days, 1 not smoky. 2 smoky days, 1 not smoky. 2 smoky days, 1 not smoky. And that covers it. And I don't know if I emphasize this enough, but you do have to add these probabilities because we're talking about all these different situations that could come up. All right, so that's our first one. I want to show you a slightly easier way to do this, and we're going to start to kind of come up with a little bit of a pattern. So let me just put this up on the screen here. Remember, we're left with 60% smoky and 40% not smoky. Okay, can you notice this pattern here where I've got the 0.6 all straight down, and then I've got the 0.4s next? Let's just focus on them, then I'll talk about what these 2 things mean right here in a second. Okay, well, remember, 0.6 stands for smoky, so this is about the number of smoky days, so it should match this. So if we're having 0 smoky days, this should be 0.6 to the 0 power, because it's 0 smoky days. Same thing here. We've got 1 smoky day, so it's 0.6 to the 1. We've got 2 smoky days, so it's 0.6 to the 2. We've got 3 smoky days, so it's 0.6 to the 3. Now, of course, if you have 0 smoky days, how many not smoky days do you have? Well, you have 3. So basically, you should have next your 0.4, and these two numbers, 0 and 3, should add up to 3. So if that's a 1, we've got 1 smoky day, we should have 2 not smoky. If we've got 2 smoky days, we should have 1 that is not smoky. If we have 3 smoky days, obviously we have 0 not smoky. So the pattern here is that the 0.6s represent this, the smoky days, and that number 0 should be the same there. Then you write out your 0.4, which is your not smokies, and then these two numbers, the 3 and the 0, they should add to 3. And we're talking about 3 because we're talking about 3 days. Okay, then your other option is, remember how before we had a lot of, let's go back. We had 3 different situations. And we don't want to have to do that every time. And it wasn't too bad for this problem because we're talking about 3 days. But if we were talking about 17 days, you would not be able to write down all those different combinations and situations. So what we want to do is introduce combinations. And what this is saying is we've got 3 days and we want to choose one of them to be smoky. And if you do 3 choose 1 on your calculator, you actually get 3, which means there are 3 possible situations. And remember how before we had 3 lines? Well, this takes care of that. It basically says we have 3 of those. And then here we've got 3 days and we're choosing 2 to be smoky. And again, if you do 3 choose 2 on your calculator, you also get 3, which takes care of those 3 lines. And so you're saying, Ms. Sorensen, I'm never going to remember this. And I'm going to say, actually, you know what? I can even expand this even further into this and this so that you can remember this pattern. I think it only takes kind of a few of these to see how to do these. And you just got to make sure you're keeping these those percentages in control, like you know which one stands for which. Okay, so we've got 0.6 to the 0. We're good with this. We're good with this. We're good with those. But now we've got 3 days and we're choosing 0 to be smoky. Choosing 0 because of this. Here, 3 days, choose 1. Choose 1 because of this. 3 days, choose 2. And then 3 days, choose 3. Choose 3 days to be smoky because of that. This is how I'd like you to leave your answer. I don't need you to find the actual values. I'm okay with you just leaving it just like that. All right, let's try to do this. If you'd like to pause the video and try it on your own, you certainly can. I think that makes sense. Okay, we're back. So during July 1st and July 4th in Boston, the probability of a thunderstorm is 25%, so 0.25. And that means that the probability of not a thunderstorm is 75%, or 0.75. Make a probability distribution table for T, the number of days receiving a thunderstorm during these 4 days. You don't have to compute each number. All right, like I said, pause the video and then I want to see if yours matches my answer. All right. Because we're talking about 0 thunderstorm days, I'm going to start with my thunderstorm percentage first. So it should be 0.25 to the 0. And I just want you to check that this is correct first. Okay, 0.25 to the 0. These numbers, the 0, the 1, the 2, the 3, and the 4, should match these right here. Then the next thing you multiply by is your percentage of not thunderstorm. And since there are 0 thunderstorm days, you want to have 4 not thunderstorm days. Remember, these two numbers right here should add up to 4 in this situation because we're talking about 4 days. All right, and then the last thing you should check is that you've got 4 days and you're choosing 0 to have thunderstorms. You have 4 days, you're choosing 1 to have a thunderstorm. 4 days, choose 2 to have a thunderstorm. 4 days, choose 3 to have a thunderstorm. 4 days, choose 4 to have a thunderstorm. And that's how I want you to leave your answer. Is that making a little bit more sense with this pattern? Hope it is. All right, here we go, another problem. During the last 5 days of school, the probability of having a dress code violation at the school is 30% each day. Let V be a dress code violation, and calculate the probability distribution table for V during these 5 days. Again, pause the video. Let's see if you can get this on your own. Okay, I'm back here. You should have 0 through 5 here because we're talking about the last 5 days of school. And we are talking about a violation. So remember, a dress code violation is 0.3, which is why I've got 0.3 running all the way down here. And then these numbers 0, 1, 2, 3, 4, 5 match these. And then after doing my dress code violation, I have to write my non-violations. There they are. And just keep in mind that these numbers, these should add up to 5 because we're talking about 5 days. And then the last thing that you need to do is check that your combinations are okay. So you've got 5 days, choose 0 to have violations. 5 days, choose 1 to have a violation. 5 days, choose 2 to have a violation. 5 days, choose 3 to have a violation. 5 days, choose 4 to have a violation. 5 days, choose 5 to have a violation. Okay. This is our last one. I want you to pause the video and see if you can get this done even faster than the last one. Okay, we're back. So you should have something that looks like this. And notice that 0.2 is a mention of fortnight. Okay, and I should have had F here. That's my bad. Probability of F. Okay, so the mention of fortnight is going to be the 0.2 first because we're mentioning fortnight 0 times. So you should 0.2 to 0. And then that goes all the way down 0, 1, 2, 3, 4, 5. And then we have to address our not mentioning fortnight. And here, if we're mentioning fortnight 0 times, we should have a 5 here. Okay. And then I've already stated this pattern enough, but these two should add to the number of times that's in your problem. In this case, it's 5. And then the last thing that you should check is that your combinations are right. So you got 5 days, choose 0 to mention fortnight. 5 days, choose 1 to mention fortnight, etc. All right, I know this was confusing at first, but hopefully after doing many of these problems, you feel pretty comfortable with it. Thanks so much for watching.